Microsoft Teams. I'm going to do the same Shouty McShoutface demo that I did the other day. So the idea of this program is to take a string of text on our disco boards and turn all of the characters into uppercase characters if they were lowercase characters. So I did this in the lecture yesterday, and I thought I'd just do it again here on the stream just as a demo of how this might work for the rest of the course. And it's actually kind of a cool program to be doing because so far in the course, all of the programs you've done have been really simple, adding a few numbers together, changing a number, moving around with very small number of branches. But today in making this program, we're going to do something which actually does some substantial work. It's got a while loop, it's got if-then-else conditions, and it's just a little bit more complicated. So I would call it kind of the first real program that we do in Comp 2300. So let's get started with it. Now the first thing I want to do is add a little bit of text into my program. So I'm going to make a data section in my code which will get the linker to put some information directly into SRAM where we can access it in our program. And I'm just going to make a label for my string, Charles string. So previously we were storing some data in memory and I was using the word directive to add one word at a time into my program. But now I want to add a string of ASCII characters. Now ASCII characters is a way of encoding the letters of the alphabet into ASCII text. I think you've tried this in your labs and some people will have some experience with this. The idea with ASCII encoding is that each letter in the English language gets transformed into a number which takes up 8 bits. So each ASCII character takes up 1 byte of space. So that's really convenient. We can then load them and store them in memory using the byte versions of load and store. So the way to put some ASCII text in your program is to type ASCII, or in fact I'm actually going to use ASCIIs, which puts a 0 at the end. That will be important a bit later. And then put my string of information after that. Computers are fun. So I've just got a string of text and this bit will be put into memory when I run my program. It's actually not going to get put into memory right now. I actually have to make sure that I use this label in my program, otherwise the linker doesn't pay any attention to it. So I'm just going to use the loader trick that I showed you before for loading any label, or the address of any label into memory with the equals sign. Oops. Letter R10 equals Charles string, so that's going to put the address of this label Charles string into that register R10. And now I'm going to just load up the first character of it into R0. How about that? So load 1 byte at this address, stored in R10, which is the address Charles string, into this register R0. Okay, let's run this program and see how it goes. So I've already got my disco board connected. Now before I run anything, I might just try looking in memory to see whether that information has been stored in the way that I wanted it to be. So I'm going to type in the memory address for the first address in SRAM. It's going to be 32 bytes. And you can see here that I've got my string, computers are fun, stored here in memory. And actually this first, let's move that over a little bit. This first byte, C, is right here. 63, OX63 is the hex number which represents lowercase c in ASCII encoding. And if I step down through my program, load R10, load Charles string, the address into R10, I get 2000000 into R10. And then I also can load that 1 byte, R0, into R0. So I've got that OX63 in R0 already. Now you might be wondering, what are all of the ASCII encodings for these letters? And it's quite easy to find that out. You just have to type man ASCII. Well, I already just did it before. if you've got your terminal ready, which you should do when you're programming, you can type man ASCII and find a list of all of the ASCII characters or their encodings. So you can see here that the character A is going to be hex 41 and decimal 65. It's got it in octal as well, in case you're an octal aficionado. And A, B, C is hex 63, and is 99 in decimal. So that was correct. That's what we had in our program already. Now, if we just head back to VS Codium, I can start transforming this letter. But you might wonder how we're going to transform it from a lowercase letter into an uppercase letter. And actually, you can see that this number is 99 for C, and the number for capital C is 67. And in fact, all of the letters, all the uppercase letters are lower than the lowercase letters, and they're lower by a set number of places in this encoding. So we can actually take an A and subtract 32 from that, from 97, and that would give us 65. So we can transform letters by subtracting 32 from their decimal value, or I guess the hex versions of that if we wanted to. So let's just go back into my program, and I've already loaded this C, the first letter, into R0, and I'm just going to sub R0 32. So taking away decimal 32 from that, and then I might store it back where I found it in R10, in the address location stored in R10. So I'll just run this program, and we'll see how it goes. Okay, here we are, loading up Charles string, the address into R10, that worked. Loading 63 into R0. We're going to subtract 32 from that. You could also subtract 32 by using some bit clears and bit operations, but I'm just going to use the regular subtract operation. And then I'm going to store that byte back, and we'll see what happens. I'm just going to move over to the ASCII representation of this text. The memory viewer handily has this way of showing us the ASCII representation. If you just scroll to the right, you'll see we often store ASCII characters in memory, so it's a handy way of looking around. So when I store that back, lo and behold, the lowercase c turns into a capital C, which is great. So now we can just run a little loop and go through our whole string, and that should be fine, right? Let's find out what happens. So maybe I'll just put a branch at the top here. Oops. I'm going to make a label actually. I'm going to make a branch label, or sorry, start loop label. And then down here, I'll branch back to that label. So as you'll know from the lecture on loops, we have to use labels and branching to make these kind of control structures work. Now, if I do this, I'm just going to keep loading up that same letter, changing it and storing it back, which is not what I want to do. I need to move through these bytes of memory one by one. So my first one will be 2 followed by 7 zeros. Then I want to add 1 to that and get 2 followed by 6 zeros and a 1, and 2 to that, 3 to that, so on. So I might make another value for my offset, which I'm going to add to the base address each time. I might just store that in R9. So I'm just going to mov R9 0 to start with. And then at the start of the loop, I'm going to use R8 to store the actual address that I want to load my information from. R8 plus equals R9 plus R10. And then at the end of the loop, I'm going to have to increment that value. So I'm going to have to add 1 to the value in R9 each time. Add R9, 1. Okay, this should work. I might need to change that to R8, which is the offset memory address, which I'm going to look at. Just checking what's going on in the chat. everything seems fine. There's a little bit of artifacting when we're doing these streams over OBS and to Microsoft Stream, so hopefully we can iron out some of these issues, but I think it's broadly working. Okay, so I've got my R10 organized, moving 0 into R9. Now I'm in the after the loop label. I'm going to calculate my offset address. In this instance, R9 is 0, so it hasn't done anything. Load up that C, change it, store it back. We can see we've got a capital C. And I might just run through this loop a few more times. So we can see we've got this label changed to 2, 6 zeros and 1. Loading up the next letter, subtracting 32, storing it back, and I've got a capital O. And I can keep going through this and capitalize all of the numbers, all of the letters in this string. Well, that's pretty cool. So maybe you can guess what's going to happen in a second, because as I go through this this procedure, there's no way for my loop to stop. In fact, when I get after I'm just doing the U, now I've got the N. Okay, now what happens after that? We're starting to just add these A's with a grav after that. So that's not what I wanted at all. I really wanted to stop at the end of this string and not continue any further. So you remember right at the start, I used this ASCII directive instead of ASCII. And what this is going to do is it's going to make sure that there is a 0 after the end of my string in memory. And now I've happened to overwritten that 0 with an E0, but if I start the program again, it will be a 0. So what I can do is run through my program, run through this loop, and then each time check whether I've loaded up a 0. And if I have loaded up a 0, then I'm going to stop it. So what I'm actually making is a kind of while loop. So when the condition for continuing the while loop is that the letter we load isn't 0. And if it is 0, then we escape the while loop. So I'm going to put in the condition right here at the start, right after the load. We need to have that value in memory already, or in a register, so we can check whether it's a 0 or not. So I've already loaded the letter into R0, and I'm going to say compare R0, 0. So this is, whoops, this is loading up our letter. Load the letter. Check if it's 0. Then I'm going to branch to somewhere I want to escape to. Maybe I'll branch down here. Branch, and, oh, sorry, I need to make the label first before I can branch. End of string. And I might make a little infinite loop here so it doesn't escape that area. B, end of string. Okay. Infinite loop when we are finished. Checking if it's 0. Now I'm going to do a conditional branch. We talked about this a lot in the lectures. I'm going to type BEQ. So if it turns out that R0 and 0 are equal, then the conditional branch instruction will execute, and our program will end up down in this infinite loop. I'll type in here end of string. Okay. So this is exciting, isn't it? Now we're just about to have this working. I might just try the first letter and see how it goes. Okay, so loading up our offset and our memory address, adding the first offset, loading in the letter, check if it's 0. We can see in the program status register, oops, that the 0 flag is not set, so it's not going to be 0. So that when I run that line, it just moves right on past it. Because they're not equal, then it's not going to take that branch. If they were equal, it would take it. And then we can go on adjusting all the letters. Now it's going to be a bit boring if I kept pressing down, so I'm just going to press this continue button, and then we'll pause the program in a second. It will have done many iterations in that time, but we can see where we end up. Hopefully it will capitalize our string, and we'll end up in the infinite loop area. Okay, pause. Great, so we've ended up in the infinite loop area. That's where execution is up to. And our string is capitalized. Excellent, so we're done, right? Or are we? What if I start adding some extra characters in here? 1, 2, 3. I might just add a special character at the start as well. So for exclamation mark, space, and numbers, we don't have lower and uppercase versions of them. We only have lower and uppercase versions of the regular characters, the alphabet, 26 letters. So subtracting these ones by 32 is probably not going to work. Let's just see what happens when I do run my program with this more interesting string. Okay, so now I've got all these letters put into memory with a 0 after it. And if I press continue, okay, it's gone into the infinite loop, which is good, nothing's broken. But you can see that all of those letters, the exclamation marks and the numbers have disappeared. The subtracting 32 didn't do what we were expecting. It hasn't turned them into a capitalized version. It's ruined the ASCII text now. So what I need to do is check if our characters are within the alphabet and only change characters in the alphabet and not change characters that are not, or actually not change capital letters either. So if we go back to my list of all of the letters, we can see that A here starts at 97 and Z is at 122. So I'm going to, after I've loaded my letter, I'm then going to check if that number is less than 97, and if it is, I'm not going to do anything. I'm going to move on to the next loop. I'm also going to check if that number is greater than 122, and if it is, I'm not going to do anything. I'll just move on to the next iteration of the loop. So let's write that in assembly programming. So I'm actually going to have to put in another label down here just before the increment. Loop increments. I'll just skip that underscore. Okay, so I've already got my byte loaded. Exit string if 0. So now I'm going to check if it's less than 97. Compare our 0 with 97. Check if less than 97. And if it is, I'll use the branch if less than. I'll just move straight down to the loop increment. Okay, that was easy. I'll do the same thing for greater than 122. Compare our 0, 122. Check if greater than 122. BGT for be greater than loop increments. Okay. And then this bit actually does the work. To capitalize. Oops. Okay, so let's give this a try. I'll stop that, run my program again. Load up that value. Getting boring now going through these things we know have worked. Load up the first letter. We'll just see if this one works and then I might press continue. So it's past that. Oops. Oh, right, sorry. It was right. The first letter in my string was an exclamation point, not a C. I got confused for a minute. It's working as expected, yeah. So we've got OX21 in R0. It's detected that that's less than 97 correctly, and then taken the else part of our little if and else check. So now I can increment, go back to the top. Now we should be loading the C, 63, that's good. And we can check that that's right. Yep, blowing through those conditional branches. Okay, we're fine. This wasn't such a disaster after all. I didn't actually need the little pound signs there. it was working. So I'm going to run continue. We can see we've got our first 2 letters done, and we'll see if it works. Okay, pause that. Great, now we can see in the memory view that I've got the exclamation points are preserved. That's great. And I've got all my letters capitalized and my spaces preserved as well. So this is the program that I wanted to write. Now we've got this short assembly program which uses a loop. It uses a couple of conditional checks. We've got a couple of if-thens to check if our ASCII values are correct or the right ones that we want to modify. And it works on a string that I've stored in memory. So this is kind of the first significant program that we've written in our little lecture demos. And I would encourage you to give it a go yourself on your computer just to make sure that you understand how these loops, labels, and conditional branches are all working. So I think that's all I'm going to do for the stream today. I'll move it back to the waiting screen and catch you guys later.